Hi there, thank you for checking out this channel. I'm Sir Sandro, and in this video, I'm going to continue my discussion on laws of exponent part 2. Let's go! All right, let us be reminded by our goal or target for this particular video. You are expected to become adept with the laws of exponents and utilize the same skills to simplify expressions using the laws of exponents and to simplify expressions involving parentheses and exponents. But in this particular video, we're just going to discuss three laws of exponents. And these are the quotient rule, the power of the quotient rule, and the zero exponent rule. Before we proceed to these laws of exponents, in the first video, we tackled about property number 1, 2, and 3. We have the product rule, the power of a power rule, and the power of a product rule. So just a short recap. We have, for the product rule, if we are multiplying two expressions, say a to the m and a to the n, but of course, the base should be the same. We just copy the base and add the exponent. We have to restrict a not equal to 0, all right? For the second property, we have the power of a power rule. So if you have here the expression a to the m, and that is being raised to another power, which is n, all you have to do is to copy the base and just multiply the two powers, m times n, where a is not equal to 0. And of course, property number 3, the power of a product rule. Say, for example, this is like a distributive in nature because you have to distribute this power to the exponent of each variable or constant. So in this case, we have a to the m times a to the n, where a is not equal to 0. So let us start our discussion with this illustration and example. Say you have x to the fourth, you divide it by x squared. We can expand x to the fourth as x times x times x times x. And we can also expand x squared as x times x. We know that we can use the cancellation, right? We can use the cancellation, like this x should be canceled here. This x can be canceled here. And you are left with x times x, which is equal to x squared. All right. Next one, another illustration. If I have 6x to the 6 divided by 72x to the fourth, all right? Again, in this case, we have a numerical coefficient for x to the 6, and that is 6. And for the x to the fourth, we have 72 as our numerical coefficient. 6 over 72, right? And then we have x to the 6. We can have this as x times x times x times x times x times x. 6 times, no? 6 times to use x as a factor. Right, we have x to the fourth, x times x times x times x. So we can use our cancellation. We have x here, another x, and then let's change the color. We have another x, and this one. And we're just going to copy. How about 6 over 72? Can we cancel 6? What is the GCF of 6 and 72? What do you think? 6, right? We can cancel the 6. Yan. And this will become 1. And 72 divided by 6. Divided by 6, that is equal to 12. All right. And then just simplify. That is equal to 1 times x, that is x times x over 12, right? In short, we have x times x, x squared over 12. And this is our final answer. Now, I just want you to observe I want you to observe x squared, x to the fourth over x squared. The answer of that is x squared, right? We have 6x to the 6 divided by 72x to the fourth, and the answer is x squared over 12. What pattern do you see? If you observe here, we just subtracted the 2 from 4. That's why it became x squared. And in this case, x to the 6 over x to the fourth, 6 minus 4 is just 2, right? And then that is over 12 because we have to simplify 6 over 72. All right, with these two examples, we are going to generalize our property number 4, and this is the quotient rule. Property number 4, the quotient rule. The quotient rule. In this case, class, the quotient of two expressions with the same base can be simplified by obtaining the difference between the exponent of the numerator and the exponent of denominator. So algebraically, we can write this as, we can have a to the m over a to the n is just equal to a raised to m minus n, where a is not equal to 0. Okay, let's enclose this with a box because this is our property number 4, the quotient rule. Again, take note that it is always the numerator's exponent minus the denominator's exponent. Okay, so let's have another example and we will apply the quotient rule. For example number 3, we have m to the fourth times n cubed over m squared times n squared. Okay, that's the given. M to the fourth n cubed over m squared n squared. All right. So this is equal to, we have here m to the fourth and m squared. So let's copy the m, copy the base, and subtract the exponent of the denominator to your numerator. So 4 minus 2. Again, 4 minus the denominator, the exponent of the denominator, which is 2. So 4 minus 2. And then n, let's have the n cubed n squared. So we have n raised to 3 minus 2. Okay, just do your arithmetic. We have m, 4 minus 2 squared, and 3 minus 2, 1. So that is just n. This is the final answer, m squared times n. Okay, isn't it cool? Let's proceed to example number 4. Example number 4. How about if we have a more complicated example? Negative 24 x to the 8th power, y to the 6th power, z cubed over 8 x cubed, y to the 4th, z. Now, I want you to pause this video and try to solve it by yourself. Okay, and then after solving it, resume. Okay, continue watching this video and we'll see if you got the correct answer. Come on, don't cheat, huh? All right, did you solve? Did you solve? Are you sure? Okay, let's go. Let's solve this one. We have here numerical coefficient, which is negative 24. And we also have 8 as the numerical coefficient of our denominator. So in this case, let's just divide negative 24 over 8, right? Negative 24 over 8. And then we have x to the 8th power over x cubed, we can actually separate them as this. X to the 8th power over x cubed times y to the 6th power over y to the 4th. And then we have times z cubed over z. Anyway, these are just multiplications. Negative 24 times x to the 8 times y to the 6 times z cubed. So we can separate them. Negative 24 over 8 times x to the 8 over x cubed times y to the 6 over y to the 4th. And then z cubed over z. And then just do your or apply your quotient rule. So in this case, class, we have negative 24 divided by 8, that is just negative 3. X, all right, x, our exponent is 8. The exponent of our numerator is 8. And we have to subtract the exponent of the denominator, which is 3, minus 3. Then we have y. What's the exponent of our numerator? 6 minus the exponent of our denominator, 4. Z, we have cube minus, what's the exponent of our denominator? This is 1, the default exponent of z. So 3 minus 1. And then just simplify. So we have negative 3 x raised to 8 minus 3, that is just x to the 5th power, and y raised to 6 minus 4, 6 minus 4, 2, so that is y squared, and then 3 minus 1, 2, that is z squared. So the final answer is negative 3 x to the 5th, y squared, z squared. I hope that's clear. Let's proceed to the 5th property. Okay, we're done with the quotient rule. Now, in this case, this is like an extension of the quotient rule. Our property number 5 is related to property number 4, but in this case, it is like distributive in nature. So the power of a quotient rule. So if we have a fraction, when a fraction is raised to a given power, again, when a fraction is raised to a given power, then raise both the numerator and the denominator to the said power. So algebraically, if we have, for example, a over b as our fraction and it is being raised to m, okay, which is the exponent, all you have to do is to raise this to the exponent, which is m. So we have a to the m over b to the m, where b is not equal to 0. Let's start with example number 1, 3/4 squared. Okay, 3/4 squared. We know how to solve this, right? We know how to expand this. So say, for example, we have 3/4 times 3/4. This is just equal 3 times 3, 9, 4 times 4, 16, 9 over 16. But using our property number 5, which is the power of the quotient rule, we can just distribute, no, the 2. So we have 3 to the 2nd power over 4 to the 2nd power. And that is just equal to 3 times 3, 9, 4 times 4, 16. So they are just the same using the power of a quotient rule. Next example, let's involve variables. If we have example number 2, we have here 9x squared y cubed over 27 x y squared. Okay, the quantity of that is raised to 3. Before you distribute the 3, okay, you multiply this to all the exponents of the constant, the variables. Please simplify first what is inside the parentheses. Simplify muna. So we have 9 over 27. Okay, we have 9 over 27 times x squared over x times y cubed over y squared. Then let's enclose that everything by 3. No? Let's simplify first the expression inside the parentheses. So in this case, we know that 9 over 27 is equal to 1/3, right? This is equal to 1/3. And then x squared over x using the quotient rule. we have x 2 minus 1 because there's 1 there. Okay, so 2 minus 1 times y 3 minus 2. And then enclose everything by parentheses and raise it to 3. So that is equal to 1/3 x raised to 2 minus 1, that is x raised to 1, or x. And y raised to 3 minus 2, 1. So that is just 1/3, the quantity of 1/3 xy raised to 3. So see, from this form, we just used the quotient rule first. It became this one. All right, so after applying the quotient rule, after simplifying this, then we have to apply the power of a quotient rule. This is distributive in nature. So in this case, we can rewrite this as xy over 3, right? Just to get rid of that one, we have xy over 3 raised to 3. And we have to distribute the 3, multiply it to the exponent of each variable, and including the constant. So in this case, we have x raised to 3, y raised to 3 over, okay, 3 raised to 3. Okay, so sir, where did the 1/3 go? We just simplify this. 1 times xy is xy over 3. So the 1 is hiding here. Right. So we have x cubed, y cubed over 3 cubed. Answer, let's simplify. This is equal to x cubed, y cubed, x cubed, y cubed. 3 cubed is just equal to 3 times 3 times 3, 27. So this is our final answer. All right, let's go to the last rule that we are going to tackle, the third one, which is the zero exponent rule. Okay, our property number 6, which is the zero exponent rule. But before I disclose the rule, I want you to investigate first. We know that 3 over 3 is just equal to what? 3 over 3 is equal to 1, right? We have 100 over 100. This is just equal to 1. That's right. If we have x over x, this is still equal to 1. If we have m over m, mn over mn, that is just equal to 1, right? So if we have here, we are going to apply the quotient rule. Sabi ni quotient rule, if we have a to the m, for example, over a to the m, we know that this is equal to 1 because a number divided to itself is just equal to 1, except for 0, because 0, there's an exception for that. 0 over 0 is not equal to 1. It's indeterminate. It's beyond our study for this particular course. So in this case, a to the m over a to the m, we know that this is equal to 1, right? A to the m over a to the m is equal to 1. But applying the quotient rule, sabi ni quotient rule kasi, if we are dividing two expressions with the same base, all we have to do is to copy the base and then minus the exponent of the denominator to the exponent of the numerator. So in this case, it happened that the exponent of our numerator and denominator are the same. That's why this is equal to a, m minus m, 0. So therefore, both are the same, right? A to the m over a to the m is equal to 1. And using the quotient rule, we have a raised to m minus m equals a to the 0. That's why we have this third property, a to the 0 is equal to 1. Right? Diyan ang galing yung property number 6 natin na zero exponent rule. Yung iba, sinasaulo lang yung fact na yan, mathematical fact that any number or any variable, except by 0, of course, you raise it to 0 is equal to 1. But they don't know where did that mathematical fact come from, right? Today, I have just showed you through this illustration. So now let us formally write our property number 6. Property number 6, which is the zero exponent rule. So the zero exponent rule, any non-zero base raised to the 0 power is equal to 1. I'm going to write that. Any non-zero base raised to the 0 power is equal to 1. So algebraically, amo to kagina ang aton nga gin-derive, we have a to the 0 raised to 0 is equal to 1, where a is not equal to 0. Okay, where a is not equal to 0. So this is our property number 6. Okay, let's have an example here. Number 1. If I have 4x, the quantity of 4x raised to 0, so let's talk about the base and exponent. So since this one, the 4x is enclosed by parentheses, so we know that the base is 4x, right? So everything is raised to 0. That's why this is equal to 1. All right? Example number 2. Example number 2. What if I have 4x to the 0? In this case, what is our base? What is our base? Our base is x. Only x, right? Only x. So in this case, we have the base, which is x. So x to the 0 power, it is equal to 1. But 4, okay, let's copy the 4, multiplied to x to the 0, that is 1. And the answer is 4. Okay, be careful with that, huh? The one that has parentheses and the one that doesn't have parentheses. And let's have the number 3. Number 3. What if you have negative 5 raised to 0? What about that? So we have this negative is not enclosed. The negative 5 is not enclosed by parentheses. So all we have to do is to copy the negative, and the 5 here is our base. This is our base. And 5 is being raised to 0. So that is equal to 1. Negative times 1 equals negative 1. All right. And the last example, let's have the last example. The last example, what if I have y to the 0 plus y plus x to the 0 power? Y to the 0 is just equal to 1 plus x to the 0 is just equal to 1. So 1 plus 1 is equal to 2. And that ends our laws of exponent part 2. Again, let's recap the 3 laws of exponent that we discussed today. We have the quotient rule, the power of the quotient rule, and the zero exponent rule. And if you're new to this channel, please like, subscribe, and hit the notification bell below for you to be updated of the upcoming videos. Bye for now.